Hello there, and welcome to Get Sleepy Science. I'm so glad you found your way here tonight. The Earth beneath our feet is ancient and powerful, constantly reshaping itself through forces that have existed for billions of years. Tonight, we'll drift gently through the science of natural disasters, exploring the beautiful and fascinating truths about how our planet moves, breathes, and transforms. Wherever you are right now, perhaps with the gentle sound of rain outside, or in the quiet stillness of a calm evening, allow yourself to settle into this shared moment of peace. Tonight, explore 100 remarkable truths about Earth's most powerful natural events. From the slow grinding of tectonic plates deep underground to the swirling patterns of hurricanes seen from space, to the ancient volcanic forces that have shaped continents over millions of years. If these calm stories from Earth's natural rhythms help you breathe easier, a gentle like and subscribe helps another sleepless soul discover this peaceful space. It only takes a moment, and it means the world to us, one sleepy soul at a time. For now, you don't need to do anything at all. Just let your shoulders soften, let your breathing fall into its own natural rhythm. Imagine yourself drifting above the Earth, watching its slow dance of creation and change from a place of perfect safety. Now, if you're ready, let's begin our quiet journey through the forces that shape our world. Now, if you'd like, close your eyes and take a deep breath. Imagine you're floating in the deep ocean, where pressure and stillness create miraculous life, moving without boundaries, without destination. Only the gentle sway of water currents and ancient stone beneath. Let go of all limits. Let your mind drift through the quiet depths of Earth's patient transformations. And when you're ready, begin. Earth's crust is broken into massive pieces that float on molten rock below. The surface of our planet isn't one solid shell, but rather a puzzle of 7 major plates and many smaller ones, all drifting slowly across the partially molten layer called the asthenosphere. These tectonic plates move at roughly the same speed your fingernails grow, about 2 to 4 centimeters per year. Yet, over millions of years, this gentle movement has created every mountain range, ocean basin, and continent we see today. When these plates meet, they can slide past each other, collide, and buckle upward, or one can slip beneath another in a process called subduction. Most of Earth's powerful natural events, earthquakes, volcanoes, tsunamis, happen along these plate boundaries, where the patient forces of geology become suddenly visible. Earthquakes are not random but follow predictable patterns across the globe. If you were to plot every earthquake that occurred on Earth in a single year on a map, you'd see clear lines emerging, the boundaries between tectonic plates lighting up like pathways traced in the dark. The Ring of Fire, a horseshoe-shaped zone around the Pacific Ocean, accounts for about 80% of the world's major earthquakes and 75% of its active volcanoes. This isn't coincidence, but geometry. The Pacific Plate is surrounded by other plates, creating zones of intense geological activity. Scientists can map where earthquakes are likely to occur based on these plate boundaries, though predicting exactly when remains one of geology's greatest challenges. The Earth keeps its own schedule. An earthquake happens when stress between rocks suddenly releases. Deep underground, rocks are constantly being pushed, pulled, and twisted by the movement of tectonic plates. For years, decades, or even centuries, these rocks bend and deform elastically, storing energy like a stretched rubber band. Eventually, the stress exceeds the strength of the rock, and it breaks along a fault line, a crack in Earth's crust. The stored energy releases in waves that radiate outward in all directions. These seismic waves travel through solid rock at speeds between 3 and 8 kilometers per second. The actual rupture lasts only seconds, yet those seconds hold centuries of patient pressure, building slowly in the darkness below. Time moves differently underground. The magnitude scale measures earthquake energy, not damage or size. When you hear that an earthquake measured 7.0 on the Richter scale, or more precisely, the moment magnitude scale we use today, that number represents the amount of energy released at the source. Each whole number increase represents roughly 32 times more energy. A magnitude 7.0 earthquake releases about 1,000 times more energy than a 5.0 quake. Interestingly, the Earth experiences about 1 million earthquakes per year, but most are so small that only sensitive instruments detect them. Only about 100 are strong enough to cause significant damage, and truly devastating earthquakes of magnitude 8.0 or higher occur, perhaps once a year. The planet trembles constantly, mostly in whispers. Seismic waves come in different types, each revealing something about Earth's interior. Primary waves, or P waves, compress and expand rock as they travel, moving fastest through the planet's interior, up to 8 kilometers per second in some deep layers. Secondary waves, or S waves, move rock side to side and only travel through solid material, which is how scientists discovered that Earth's outer core is liquid. Surface waves travel along the planet's crust and cause most of the shaking we feel during earthquakes. By studying how these different waves move through Earth, seismologists have mapped our planet's internal structure without ever drilling more than 12 kilometers down. The Earth tells its secrets through the way it rings like a bell when struck. Volcanoes are windows into Earth's fiery interior. Beneath the solid crust, temperatures rise dramatically, about 25 degrees Celsius for every kilometer of depth. At depths of 100 to 400 kilometers, rock becomes partially molten, forming magma. This magma is less dense than the solid rock around it, so it slowly rises, gathering in chambers beneath the surface. When pressure builds sufficiently, magma forces its way upward through cracks and weak points in the crust. Once it reaches the surface, we call it lava. Every volcanic eruption is essentially the planet releasing internal heat and pressure that has been building, sometimes for thousands of years. Volcanoes are not threats but release valves, allowing Earth to breathe. Most volcanoes occur at plate boundaries, following the same patterns as earthquakes. Where plates pull apart, such as along the mid-Atlantic ridge, deep beneath the ocean, magma rises to fill the gap, creating new seafloor. Where one plate slides beneath another, the descending plate melts as it sinks into the hot mantle, creating magma that rises to form volcanic arcs, chains of volcanoes like those in the Andes or the Aleutian Islands. A smaller number of volcanoes occur at hotspots, places where plumes of especially hot mantle material rise from deep within the planet. The Hawaiian Islands formed this way, each island a volcano that the Pacific Plate carried northwestward as new volcanoes formed over the stationary hotspot. Volcanic eruptions vary tremendously in their character and power. Some volcanoes, like those in Hawaii, produce relatively calm eruptions where lava flows steadily from vents, sometimes for years at a time. These effusive eruptions happen when magma has low gas content and flows easily. Other volcanoes erupt explosively, hurling ash, rock, and gas high into the atmosphere. These explosive eruptions occur when magma is thick and gas-rich. Pressure builds until it exceeds the strength of the overlying rock, and the mountain releases its pressure suddenly and powerfully. The 1980 eruption of Mount St. Helens in Washington state removed the entire north face of the mountain in seconds. Yet even these powerful events follow physical laws, patterns we can observe and, increasingly, predict. Volcanic ash isn't really ash at all, but tiny fragments of rock and glass. When magma explodes during an eruption, it shatters into countless pieces, ranging from fine dust to fist-sized rocks, called volcanic bombs. The tiniest particles can be carried thousands of kilometers by high-altitude winds. The 2010 eruption of Eyjafjallajökull in Iceland grounded aircraft across Europe for weeks because volcanic ash can damage jet engines. But volcanic ash also enriches soil. Some of the most fertile farmland on Earth lies near volcanoes, nourished by minerals from ancient eruptions. What seems destructive in the moment becomes, over centuries, the foundation for abundant life. Tsunamis are not single waves, but series of waves, sometimes arriving hours apart. These massive ocean waves form when something suddenly displaces large amounts of water, usually an underwater earthquake, but also submarine landslides or volcanic eruptions. In deep ocean, a tsunami might be only a meter high but travel at speeds approaching 700 kilometers per hour, as fast as a commercial jet. As these waves approach shallow coastal waters, they slow down but grow dramatically taller, sometimes reaching heights of 30 meters or more. The 2004 Indian Ocean tsunami, triggered by a magnitude 9.1 earthquake off Sumatra, traveled across entire ocean basins, reaching shores thousands of kilometers away. The ocean has a long memory for disturbances. Between tsunami waves, the ocean often pulls back dramatically from the shore. This phenomenon, called drawback, happens because a tsunami is not like a normal surface wave, but rather a disturbance of the entire water column from surface to seafloor. When the trough of a tsunami wave reaches shore first, the water level drops suddenly, sometimes exposing the seafloor far beyond the normal tide line. This temporary retreat is not the end of the event, but a warning that the crest of the wave is approaching. Historical accounts describe people walking out onto the exposed seafloor, curious about the sudden retreat of the sea, moments before the wave arrived. Nature often provides warnings if we understand its language. Hurricanes are massive heat engines powered by warm ocean water. These rotating storm systems form over tropical oceans when water temperature exceeds about 26 degrees Celsius. Warm, moist air rises rapidly, creating low pressure at the surface. As more air rushes in to fill this void, Earth's rotation causes it to spin, creating the characteristic spiral structure. The rising air releases heat as water vapor condenses into clouds and rain, which powers more upward motion, creating a self-reinforcing cycle. A mature hurricane can be 500 kilometers across and contain more energy than several nuclear weapons. Yet, despite this power, these storms are fragile. They quickly weaken once they move over land or cold water, their fuel supply cut off. The eye of a hurricane is a region of calm at the storm's center. Here, air is sinking rather than rising, clouds clear, and winds are light. The eye can be 20 to 40 kilometers across, a circular sanctuary of blue sky surrounded by the eye wall, where the storm's strongest winds occur. Pilots flying through hurricanes describe the transition as dramatic, from violent turbulence and darkness to sudden calm and sunlight, then back into the storm on the other side. This calm center exists because of the hurricane's rotation, the same physics that keeps water in a bucket when you spin it fast enough. Even in nature's most powerful storms, there is always a center of stillness. Hurricanes, typhoons, and cyclones are the same phenomenon with different names. These tropical storms are called hurricanes in the Atlantic and Eastern Pacific, typhoons in the Western Pacific, and cyclones in the Indian Ocean and South Pacific. The naming difference is purely geographic tradition. All are tropical cyclones, rotating storm systems with organized thunderstorms and winds of at least 119 kilometers per hour. Interestingly, these storms never form within about 5 degrees of the equator. Although they need warm water, they also need the Coriolis effect, the deflection of moving objects caused by Earth's rotation, to start spinning. Near the equator, the Coriolis effect is too weak, creating a hurricane-free band around the planet's middle. Even chaos needs the right conditions. Tornadoes are the most concentrated form of atmospheric energy on Earth. These violently rotating columns of air form beneath thunderstorms when wind shear, changes in wind speed or direction with height, creates horizontal rotation in the atmosphere. Rising air in the thunderstorm can tilt this rotation upward, creating a mesocyclone. When this rotating column extends from cloud to ground, it becomes a tornado. The strongest tornadoes produce winds exceeding 300 kilometers per hour. The most violent can reach nearly 500 kilometers per hour. Yet they're typically less than half a kilometer wide and last only minutes. Despite their brief existence and small size, tornadoes represent an incredible concentration of energy. All of nature's power focused into a spinning column that touches down, transforms the landscape, and vanishes. Tornado Alley in the United States sees more tornadoes than anywhere else on Earth. This region, stretching from Texas northward through Oklahoma, Kansas, and Nebraska, provides perfect conditions for tornado formation. Cold, dry air from Canada meets warm, moist air from the Gulf of Mexico, while jet stream winds aloft create the wind shear needed for supercell thunderstorms. The flat terrain allows these contrasting air masses to collide without interference from mountains. While tornadoes occur on every continent except Antarctica, this unique geography makes Central North America exceptionally tornado-prone. The Earth's shape and rotation, ocean currents, and mountain ranges all conspire to create specific regions where certain phenomena concentrate. Geography is destiny, in weather as in life. Floods are the most common natural disaster worldwide, affecting more people than any other event. Rivers have always flooded. It's part of their natural cycle. Spring snowmelt, heavy rains, or dam failures can cause water levels to rise beyond the river's normal channel. Floodplains, the flat areas beside rivers that occasionally fill with water, are actually deposits from thousands of years of floods. This is why they're often so fertile. Each flood leaves behind nutrient-rich sediment. Humans have long built settlements near rivers for fresh water and transportation, accepting periodic flooding as the price of these benefits. Only recently have we tried to control floods rather than adapt to them, a shift that has paradoxically made flood damage worse when our controls fail. Droughts develop slowly, but can persist for years, even decades. Unlike sudden events like earthquakes or tornadoes, drought is the gradual absence of sufficient precipitation. Plants wilt, soil dries and cracks, water sources diminish. Some droughts follow predictable patterns. El Niño events, shifts in ocean temperature patterns across the Pacific, reliably bring drought to some regions and excess rain to others. Other droughts emerge from complex interactions between atmospheric circulation, soil moisture, and even human land use. The Dust Bowl of the 1930s in North America resulted partly from natural drought, but was worsened by farming practices that exposed soil to wind erosion. Earth's systems are interconnected in ways we're still working to understand. Wildfires are a natural and necessary part of many ecosystems. Certain forests have evolved with fire. Some pine cones only release their seeds after exposure to intense heat. Without periodic fires, these forests become overgrown with underbrush and small trees, eventually facing even more intense fires. Indigenous peoples understood this, using controlled burns to manage forests for thousands of years. Modern fire suppression policies, though well-intentioned, have sometimes led to accumulations of fuel that make fires more severe when they do occur. Fire, like flooding, is not inherently a disaster but a natural process. The challenge is finding ways to live alongside these processes rather than trying to eliminate them entirely. Nature has its own logic. Lightning triggers many wildfires, especially in remote wilderness areas. Each lightning strike carries enough heat to ignite dry vegetation. In the western United States, dry lightning that occurs without significant rainfall, causes thousands of wildfires each year. These fires can burn for weeks or months in remote areas before being discovered. Interestingly, fire seasons are lengthening in many parts of the world as temperatures warm and dry seasons extend. What once might have been a 2 or 3 month fire season now stretches to 5 or 6 months in some regions. The planet's climate is shifting, and these shifts manifest as changes in the frequency and intensity of events that have always occurred, just in different patterns. Landslides reshape mountains and valleys, sometimes in seconds. These mass movements of rock, soil, and debris occur when gravity overcomes the forces holding material on a slope. Water plays a crucial role. Saturated soil becomes heavy and loses cohesion, and water pressure in cracks can push rocks apart. Earthquakes can trigger landslides by shaking loose material that was barely stable. Vegetation usually helps prevent landslides by anchoring soil with roots, which is why deforestation often increases landslide risk. The largest landslides can move entire mountainsides. The 1980 eruption of Mount St. Helens began with the largest landslide in recorded history. The entire north face of the mountain collapsed, triggering the explosive eruption. Gravity, water, and geology work together to transform landscapes. Avalanches are rivers of snow that can flow at speeds exceeding 150 kilometers per hour, as fast as a race car. These occur when accumulated snow on a slope becomes unstable, often triggered by additional snowfall, warming temperatures, or vibrations from wind or earthquakes. The deadliest avalanches are slab avalanches, where a cohesive layer of snow breaks free and slides as a unit. As it descends, the snow can compress and create a blast of air that extends beyond the flowing snow itself, powerful enough to demolish structures. Despite their power, avalanches follow predictable patterns based on slope angle, snow conditions, and weather. Mountain communities have learned to read these patterns, building in safe zones and knowing when conditions are dangerous. Sinkholes form when underground cavities collapse, creating sudden depressions in the ground surface. These cavities usually form in limestone or other soluble rock through a process called karst weathering. Slightly acidic groundwater slowly dissolves the rock over thousands of years, creating caves and voids underground. Eventually, the roof of a cavity may become too thin to support the weight above, and it collapses. Sometimes this happens gradually, creating a shallow depression. Other times, especially in areas with thick soil over limestone, the collapse is sudden and dramatic. In Florida, where limestone underlies much of the state, sinkholes are common. The ground beneath our feet is not as solid as it appears. It's constantly being reshaped by water flowing through darkness. Ice ages are among the longest-lasting natural disasters in Earth's history. For the past 2.5 million years, Earth has cycled between long glacial periods, when ice sheets cover large portions of continents, and shorter warm periods like the one we're in now. These cycles are driven by subtle variations in Earth's orbit and axis tilt that affect how much sunlight different parts of the planet receive. During the last glacial maximum, 20,000 years ago, ice sheets covered Canada, Northern Europe, and parts of Asia, with sea levels about 120 meters lower than today. The transition between glacial and interglacial periods takes thousands of years, a timescale so vast that individual human lives are invisible against it. Earth's magnetic field occasionally flips, swapping north and south magnetic poles. This geomagnetic reversal has happened hundreds of times in Earth's history, most recently about 770,000 years ago. The flip doesn't happen instantly but takes several thousand years, during which the magnetic field weakens and becomes complex, sometimes having multiple poles. We know this from volcanic rocks. As lava cools, magnetic minerals within it align with Earth's magnetic field at that time, creating a permanent record. During a reversal, we'd lose some protection from cosmic radiation and solar wind, and animals that navigate using magnetic fields might become confused. Yet, life has survived every previous reversal. The planet changes in ways beyond our normal experience of time. Let's pause here and notice your body. As you breathe out slowly, appreciate each tiny cell inside. Trillions of organisms working in silence. Heart beating, lungs breathing, brain thinking, all without your command. Notice the gentle sensations on your skin, in your muscles, along your spine. You are a complete ecosystem, diverse, self-balancing, just like Earth itself, constantly adjusting, constantly renewing. Feel the pull of gravity, the same force that shapes mountains and moves tectonic plates, holding you gently against this spinning planet. Now we continue. Glaciers are rivers of ice that flow incredibly slowly downhill. These massive ice formations form in areas where more snow falls in winter than melts in summer. Year after year, snow accumulates and compresses into ice. When the ice becomes thick enough, typically about 40 meters, its own weight causes it to deform and flow like an extremely viscous fluid. Glaciers can be several kilometers thick and flow at rates from a few centimeters to several meters per day. As they move, they carve valleys, transport rocks, and reshape landscapes. The fjords of Norway and New Zealand, the valleys of Yosemite, the Great Lakes of North America, all were sculpted by glaciers during Earth's recent ice ages. Coral reefs face challenges from ocean warming and acidification, showing how slowly developing changes can be as significant as sudden events. As oceans absorb carbon dioxide from the atmosphere, seawater becomes more acidic, making it harder for corals and other organisms to build their calcium carbonate skeletons. Meanwhile, warming water causes corals to expel the symbiotic algae that give them color and much of their nutrition, leading to coral bleaching. The Great Barrier Reef, the largest living structure on Earth, visible from space, has experienced 7 mass bleaching events since 1998, with the most recent occurring in 2024. These changes happen over years and decades rather than minutes or hours, yet represent a kind of slow-motion transformation. Permafrost is permanently frozen ground, found in polar regions and high mountains. This layer of soil, rock, and organic material has remained below 0 degrees Celsius for at least 2 consecutive years, though much permafrost has been frozen for thousands of years. Permafrost can extend hundreds of meters deep, with only a thin, active layer at the surface that thaws each summer. As global temperatures rise, permafrost that has been frozen for millennia is beginning to thaw, releasing trapped methane and carbon dioxide, and causing the ground to subside. Buildings constructed on permafrost are sinking, roads are buckling, and ancient landscapes are transforming in ways not seen since the last ice age ended. Desertification is the process by which fertile land becomes desert, affecting millions of people worldwide. This transformation happens through a combination of climate changes and human activities like overgrazing, deforestation, and unsustainable farming. Once vegetation is removed, soil becomes vulnerable to wind erosion. Without plant roots to hold it in place, topsoil blows away, leaving only sand and rock. The Sahara Desert is expanding southward into the Sahel region of Africa, turning grassland into desert. Yet, this process can sometimes be reversed through careful land management and reforestation. The Loess Plateau in China has been partially restored from eroded wasteland to productive land through terracing, tree planting, and sustainable farming. Earth is resilient when given the chance. Lake effect snow demonstrates how bodies of water influence local weather. When cold air masses move across relatively warm lake water, especially in autumn and early winter, the warm water heats the air from below, making it rise rapidly. This rising air carries moisture evaporated from the lake. As the air moves inland and rises over slightly higher terrain, it cools, causing the moisture to condense and fall as snow, sometimes at rates exceeding 10 centimeters per hour. Cities on the eastern shores of the Great Lakes, like Buffalo and Syracuse, can receive several meters of snow each winter from this effect. The lakes are essentially snowmaking machines, powered by the temperature difference between water and air. Dust storms, also called haboobs, can create walls of dust and sand, several kilometers wide and 1,000 meters high. These dramatic weather events occur in arid regions, when thunderstorm downdrafts hit the ground and spread outward, lifting loose dust and sand into a towering wall that advances at speeds up to 100 kilometers per hour. Behind the leading edge, visibility can drop to zero in seconds. The American Southwest, the Sahara, the Middle East, and Australia all experience regular dust storms. As these storms pass over cities, they can halt all activity. Airports close, roads become impassable, and residents shelter indoors while the world outside turns brown. Then, as suddenly as it began, the dust settles and the sky clears. Monsoons are seasonal wind patterns that bring dramatic changes in precipitation. The word comes from the Arabic mausim, meaning season. The most famous monsoon occurs in South Asia, where winds shift direction between summer and winter. In summer, warm air over the land rises, drawing in moisture-laden air from the Indian Ocean, bringing months of heavy rain. In winter, the pattern reverses, with dry air flowing from land to sea. These rains are crucial. They provide most of the annual rainfall for billions of people. Rice paddies fill, rivers rise, and the landscape transforms from brown to vibrant green. Entire cultures have organized their calendars and activities around the coming and going of the monsoon. El Niño and La Niña are opposite phases of a climate pattern that affects weather worldwide. Every few years, ocean temperatures in the eastern Pacific near the equator warm significantly. This is El Niño. Water that is normally around 24 degrees Celsius can warm to 28 degrees or higher. This warming shifts rainfall patterns across the globe. Some regions that are normally dry receive floods, while others experience drought. La Niña is the opposite phase, when these same ocean waters become cooler than normal, creating different but equally widespread weather impacts. These patterns were recognized by South American fishermen centuries ago, who named El Niño after the Christ child because it often arrived around Christmas. Ocean and atmosphere dance together, affecting the entire planet. Rogue waves are massive ocean waves that appear without warning, even in calm seas. These waves can reach heights of 30 meters, as tall as a 10-story building. Unlike tsunami waves, which are caused by earthquakes, rogue waves form through complex interactions of wind, current, and normal ocean waves. When several wave patterns align just right, they can combine into a single enormous wave that rises suddenly, travels a short distance, then dissipates just as suddenly. Ships have reported being struck by walls of water appearing out of nowhere. Scientists once considered reports of these waves to be myths, but satellite observations have confirmed they occur more frequently than previously thought. The ocean holds sudden surprises, even in apparent calm. Submarine volcanoes are far more numerous than volcanoes on land. The mid-ocean ridges that wind across the seafloor, like the seams of a baseball, are actually chains of underwater volcanoes erupting continuously, creating new oceanic crust. Most of these eruptions go unnoticed. They occur in complete darkness, under kilometers of water, and the water prevents explosive eruptions by instantly cooling the lava. However, when submarine volcanoes grow tall enough to reach the surface, they create new islands. Iceland sits atop the mid-Atlantic ridge, where the North American and Eurasian plates are pulling apart. The island is essentially the top of a massive underwater volcanic mountain range. The majority of Earth's volcanic activity happens in the depths of the ocean, unseen and unnoticed. Maelstroms are powerful rotating ocean currents that can pull objects into their centers. These whirlpools form when tidal currents flow through narrow channels or around islands, creating eddies. The strongest maelstroms occur where particularly strong tidal flows meet irregular seafloor topography. The Saltstraumen in Norway is considered the world's strongest maelstrom, moving 400 million cubic meters of water through a narrow strait every 6 hours as tides change. While folklore depicts maelstroms as ships swallowing monsters, the reality is less dramatic, though still impressive. Small boats can be caught and spun around, but large vessels generally pass through safely. Water, given the right geography, creates its own spirals and patterns. Meteor impacts are extremely rare but have profoundly shaped Earth's history. Approximately 66 million years ago, an asteroid roughly 10 kilometers in diameter struck what is now Mexico's Yucatan Peninsula. The impact released extraordinary energy, creating earthquakes thousands of times stronger than any in recorded history, and threw so much dust into the atmosphere that sunlight was blocked for months or years. This led to the extinction of approximately 3/4 of Earth's species, including the non-avian dinosaurs. Yet life survived and eventually flourished again. The crater, now buried under sediment, is about 180 kilometers wide. Large impacts are exceptionally rare. The last similar event was over 100 million years earlier. Geysers are rare geological features where water and steam periodically erupt from the ground. These occur only where underground water is heated by nearby magma, collects in a plumbing system of cavities and cracks, and has a restricted outlet to the surface. As water deep in the system heats past its normal boiling point, pressure keeps it liquid. It eventually flashes to steam, forcing water above it, upward and out. After the eruption, the system refills and the cycle repeats. Old Faithful in Yellowstone erupts roughly every 90 minutes, shooting water up to 55 meters high. Only about 1,000 geysers exist on Earth, mostly in volcanic regions. They're beautiful reminders that our planet is volcanically active. The aurora borealis and aurora australis are not weather or geology, but interactions between Earth and the Sun. These shimmering curtains of light occur when charged particles from the Sun collide with gases in Earth's upper atmosphere. The sun constantly streams particles into space in all directions. The solar wind, Earth's magnetic field, deflects most of these particles, but some are funneled toward the magnetic poles. When they strike oxygen and nitrogen molecules in the atmosphere at altitudes of 100 to 300 kilometers, these collisions cause the gases to glow, green and red from oxygen, blue and purple from nitrogen. The aurora intensifies when the sun is more active. These lights are Earth's magnetic field made visible, protecting us while creating beauty in the polar night. Climate operates on multiple timescales simultaneously. There's the daily cycle of temperature and weather, the seasonal patterns we experience each year, and longer cycles like El Niño that repeat every few years. Beyond these are cycles lasting decades, centuries, and millennia. Ice cores drilled from Antarctica and Greenland preserve air bubbles from hundreds of thousands of years ago, allowing scientists to measure past atmospheric composition and temperature. Tree rings, coral growth bands, and ocean sediments add more pieces to this puzzle. Understanding climate means recognizing patterns within patterns, cycles within cycles. Earth's systems operating on timescales from hours to millions of years, all interconnected. If you're still awake, still listening to Earth's secrets, that means curiosity hasn't fully rested yet, and that's okay. Take a gentle breath. Feel the weight of your body on the bed, grounded like ancient stone. We're wandering through nature's quiet wisdom together, understanding the forces that have shaped continents, carved oceans, and created the very ground beneath your bed. And well, keep going, slowly. Rivers don't just carry water, they transport entire landscapes grain by grain. The Mississippi River moves about 500 million metric tons of sediment to the Gulf of Mexico each year. This sediment was once soil from fields in Minnesota, rock from mountains in Montana, particles eroded from every tributary along the way. Rivers are Earth's conveyor belts, constantly wearing down highlands and depositing material in lowlands and oceans. The Amazon, Earth's largest river by volume, discharges so much water that it reduces the salinity of the ocean up to 100 kilometers from its mouth. From space, you can see the brown plume of sediment spreading into the blue Atlantic. Rivers reshape the world while flowing endlessly to the sea. Caves are sculptures created by water working through stone over millions of years. Most caves form in limestone through chemical weathering. Rain absorbs carbon dioxide from the air and soil, becoming slightly acidic. This weak acid slowly dissolves limestone, enlarging cracks into passages and passages into chambers. Stalactites grow downward from cave ceilings, where water drips, leaving behind tiny deposits of dissolved minerals. Stalagmites grow upward from the floor where these drips land. These formations grow incredibly slowly, often less than a millimeter per year. Walking through a cave is walking through hidden architecture, passages carved by chemistry, chambers hollowed by solution, formations built drop by drop from dissolved minerals. Hot springs form where geothermally heated water rises to the surface. In volcanic regions or areas with thin crust, water that seeps underground is heated by hot rock and magma. This hot water is less dense than cold water, so it rises back to the surface through cracks and fractures. The water can emerge at temperatures close to boiling, The colorful pools in Yellowstone get their vivid hues from thermophilic bacteria, microorganisms that thrive in extreme heat. Different species prefer different temperatures, creating concentric rings of color. These simple organisms are among the oldest forms of life on Earth, thriving in conditions that would destroy most living things. Life finds a way, even in boiling water. Sand dunes are not static, but migrate slowly across deserts. Wind picks up sand grains and carries them up the gentle windward side of a dune. At the crest, the wind drops the sand, which then avalanches down the steeper lee side. This process, repeated countless times, causes the entire dune to march forward. Large dunes can migrate dozens of meters per year. The shape of dunes reveals information about prevailing winds. Crescent-shaped Barchan dunes indicate wind from one direction. Star dunes form where winds blow from multiple directions. In some deserts, ancient dunes have been buried and turned to stone, preserving the direction of winds that blew millions of years ago. Fog is simply a cloud touching the ground. When air near the surface cools to its dew point, the temperature at which water vapor condenses, tiny water droplets form suspended in air. This happens frequently in valleys at night, when the ground radiates heat away, cooling the air above it. Coastal fog forms when warm, moist air moves over cold ocean water. The Grand Banks off Newfoundland is one of the foggiest places on Earth, where warm Gulf Stream waters meet cold Labrador Current waters. Fog obscures vision because light scatters off countless tiny droplets. Yet it's just water in air, made visible. Clouds brought down to where we can walk through them. Bioluminescence in the ocean creates an underwater light show during certain natural disturbances. Dinoflagellates, single-celled organisms, produce light through chemical reactions when agitated. In areas where these organisms bloom in high concentrations, any movement through the water creates sparkles and trails of blue-green light. Waves breaking on beaches can glow. Fish swimming through the water leave luminous trails. A boat's wake becomes a river of light. This biological light pollution serves to startle predators. When something tries to eat the dinoflagellate, the flash of light might attract the attention of that predator. Yet, from a human perspective, it's simply magical, the ocean glowing in the darkness, turning every movement into light. Chemistry becomes art. Tide pools are miniature ecosystems that experience extreme conditions twice daily. When the tide goes out, organisms living in these rocky depressions are exposed to air, sun, rain, and dramatic temperature changes. When the tide returns, crashing waves bring salt water, nutrients, and sometimes predators. Yet tide pool inhabitants thrive in this challenging environment. Anemones close up to retain moisture. Crabs hide under rocks. Barnacles seal themselves in their shells. Algae and small fish wait patiently for the tide's return. These communities have adapted to extremes, making them among the hardiest ecosystems on Earth. They experience daily natural disasters and continue, resilient and patient. Meandering rivers create oxbow lakes through a slow process of erosion and deposition. Rivers naturally wind back and forth across floodplains. The outside of each curve experiences faster current and more erosion, while the inside sees slower current and deposition of sediment. Over years and decades, these curves become more pronounced. Eventually, during a flood, the river might cut straight across the neck of a tight meander, abandoning the curve. The cut-off meander becomes an oxbow lake, a crescent-shaped body of water sitting beside the river that created it. Over time, these lakes gradually fill with sediment and vegetation. Water follows the path of least resistance, constantly redrawing its own course. Cloud seeding attempts to enhance precipitation by introducing particles that water vapor can condense around. Natural clouds form when water vapor condenses onto tiny particles called cloud condensation nuclei. Dust, pollen, sea salt, or smoke particles. Cloud seeding adds more nuclei, usually silver iodide crystals, which have a structure similar to ice. Aircraft or ground generators release these particles into clouds. The effectiveness remains debated. It's difficult to prove whether rain that falls after seeding would have fallen anyway. Some studies show modest increases in precipitation, while others find little effect. It's an attempt to slightly influence natural processes that are vastly larger and more complex than our interventions. The water cycle has no beginning or end. It's a continuous movement of water through Earth's systems. Water evaporates from oceans, lakes, and soil, rises as vapor, condenses into clouds, falls as precipitation, and flows through rivers back to the ocean. But there are many loops within this cycle. Water can be stored for years in glaciers, for millennia in deep groundwater aquifers, for centuries in the deep ocean. Some water molecules have cycled through this system for billions of years. The water you drink today might have been rain that fell on dinosaurs, might have flowed through rivers that no longer exist. Water is recycled, not renewed. Earth has roughly the same amount it has always had. We've traveled halfway, and in this moment, let each breath guide you to realize time is yours, a separate stream that only you are living. While Earth continues to spin, mountains rise grain by grain, rivers carve, canyons molecule by molecule. This second, you're breathing, listening, is unique. The forces we've explored operate on timescales beyond human perception. A lifetime for us is a single heartbeat in the life of a mountain. Cherish the present moment, knowing that right now, your time is unique in the universe. And we continue drifting. Stalactites and stalagmites never stop growing as long as water drips. In living caves where water still flows, these formations continue adding microscopic layers. Scientists can date layers in stalagmites using uranium-thorium dating, reading past climate conditions from the chemistry of each layer, like tree rings. Some formations are hundreds of thousands of years old. Touch can stop their growth permanently. Oils from human skin alter the stones. Surface chemistry. These delicate structures represent unfathomable patience. Drop by drop, century by century, they reach toward each other. Sometimes they meet and fuse into a column. Petrified forests show us ancient landscapes turned to stone. Trees that fell millions of years ago in swamps or were buried by volcanic ash were gradually replaced by minerals dissolved in groundwater. Cell by cell, wood became stone while preserving the original structure in perfect detail. You can see growth rings, bark texture, even sometimes the patterns of wood grain, all in colorful agate or jasper. Entire forests have been petrified this way. What was once living and green is now stone in reds, yellows, blues, beautiful and permanent. The past literally turned to mineral. Salt flats form where lakes in desert basins evaporate. As water disappears into the dry air, dissolved minerals remain behind, accumulating over thousands of years. The Salar de Uyuni in Bolivia is the world's largest salt flat, over 10,000 square kilometers of bright white salt crust. When covered with a thin layer of water during the rainy season, it becomes the world's largest mirror, perfectly reflecting the sky. The flatness is extraordinary. The surface varies by less than 1 meter across the entire expanse. Flat as water, hard as stone, and bright as snow under the desert sun. Hydrothermal vents on the deep ocean floor create oases of life in the abyss. These underwater hot springs occur where seawater seeps into cracks near mid-ocean ridges, is heated by magma, and erupts back into the ocean carrying dissolved minerals. The water can exceed 400 degrees Celsius, but doesn't boil due to extreme pressure. Minerals precipitate out, forming chimney-like structures called black smokers or white smokers, depending on the minerals present. Amazingly, ecosystems thrive around these vents in complete darkness. Bacteria that harvest energy from chemicals rather than sunlight form the base of these food webs. Life without light. Boulders scattered across landscapes are often glacial erratics, rocks carried far from their source by Ice Age glaciers. As glaciers advanced, they plucked rocks from bedrock and carried them along. When the ice melted, these rocks were left behind, sometimes hundreds of kilometers from where they originated. Geologists can identify the source of erratics by their rock type and trace the path of ancient glaciers. Madison Boulder in New Hampshire weighs about 7,000 tons, moved by ice that melted 10,000 years ago. Ice, given enough time, moves mountains stone by stone. Limestone caves often contain ancient fossils embedded in their walls. These sedimentary rocks formed from the compressed remains of countless marine organisms in ancient seas. Walking through a cave, you might see the outline of a trilobite, a crinoid stem, or shells of extinct mollusks. The cave itself formed millions of years after the fossils were deposited, carved by water flowing through the fossil-bearing rock. What was once the bottom of a shallow ocean is now dry land, hollowed out and accessible. The past compressed into stone, the present carved through it. Desert varnish is a thin, dark coating that forms on rock surfaces in arid environments. This coating, composed of manganese and iron oxides, forms incredibly slowly, perhaps a micrometer per century. The exact process remains debated, but may involve bacteria that concentrate these metals from dust and rain. Some desert varnish is thousands of years old. Ancient peoples created petroglyphs by removing this dark varnish to expose lighter rock beneath. These images have lasted millennia because the varnish reforms so slowly. Rock surfaces in deserts slowly darken, like paintings created by time, air, and chemistry. Columnar basalt forms when lava cools and contracts, cracking into hexagonal columns. This distinctive pattern appears worldwide wherever basaltic lava flows have cooled slowly. As the rock solidifies and cools, it shrinks, and cracks form perpendicular to the cooling surface. Hexagons minimize the energy needed for cracking, so this shape dominates. The Giant's Causeway in Northern Ireland and Devil's Postpile in California showcase these natural columns, some perfectly geometric and others irregular. Lava, in cooling, creates order, geometry, emerging from molten chaos as heat leaves the stone. Ice caves form in glaciers as meltwater carves tunnels through the ice. These caves are temporary. They change with every melt season and eventually collapse or melt completely. Inside, the ice glows blue. This happens because ice absorbs red light and transmits blue wavelengths. The thicker the ice you look through, the deeper the blue. Walking through an ice cave is like being inside a sapphire. Blue light everywhere, smooth walls, the sound of dripping water. But these caves are dangerous. They're constantly melting, shifting, and reforming. Beauty and danger in frozen water. Fairy chimneys are tall, cone-shaped rock formations carved by erosion. These form in places where hard rock layers cap softer rock below. As rain and wind erode the soft rock, the hard cap protects the material directly beneath it, creating a pillar. Eventually, the cap falls off, and the remaining pillar erodes more quickly. Cappadocia in Turkey has thousands of these formations, some carved into homes and churches centuries ago. The landscape looks otherworldly, a forest of stone pillars pointing skyward, slowly growing shorter as erosion continues its patient work. River deltas are land built by deposition. As rivers reach the ocean and slow down, they drop their load of sediment. Over millennia, this sediment accumulates into fan-shaped deposits, extending into the sea. The Nile Delta, the Mississippi Delta, the Ganges Delta, all are relatively new land, built grain by grain from material eroded from mountains, hundreds or thousands of kilometers away. Deltas are some of the most fertile land on Earth, rich in minerals from upstream. But they're also vulnerable to rising sea levels and coastal erosion. Land created slowly can be reclaimed by the sea just as slowly. Quicksand is not a special type of sand, but ordinary sand saturated with water. When sand becomes waterlogged, friction between grains is greatly reduced. Weight applied to the surface causes the sand to behave like a liquid. Despite popular depictions, quicksand rarely poses serious danger. Its density is higher than human bodies, so you float rather than sink completely. The actual danger is getting stuck and then being caught by rising tides. Quicksand teaches us that solid ground isn't always solid. Matter can exist in states between solid and liquid. Thermoclines are layers in oceans and lakes where temperature changes rapidly with depth. In summer, the sun warms surface waters, while deeper water stays cold, creating distinct layers. These layers resist mixing because warm water is less dense than cold water. Divers can feel the thermocline, swim downward, and suddenly the water becomes noticeably colder. This layering affects ocean circulation and marine life distribution. As seasons change, surface water cools, and eventually the lake or ocean turns over. mixing nutrients from deep water to the surface. Water stratifies by temperature, creating invisible boundaries in fluid. Frost wedging breaks rock through the simple expansion of freezing water. Water seeps into cracks, freezes overnight, expands by 9%, and splits the rock apart, molecule by molecule, night after night. In places with many freeze-thaw cycles, this creates landscapes of shattered stone. Bryce Canyon's orange pillars stand as monuments to millions of frozen nights, where frost wedging carved irregular columns into the colorful rock layers. Each winter adds more cracks, slowly transforming solid cliffs into standing forests of stone. Ice, patient and persistent, dismantling mountains, one crystal at a time. Barrier islands are long, narrow islands parallel to coasts, separated from the mainland by lagoons or marshes. These islands form from accumulated sand deposited by waves and currents. They're constantly changing. Storms can breach them. Tides reshape them. Currents move sand from one end to the other. Despite their instability, barrier islands protect mainland coasts from storms and waves. Many have been developed for beach tourism, though this battles their dynamic nature. Buildings on barrier islands are essentially built on shifting sand. The islands want to migrate, to change, to move. That's their nature. Ice ages don't end suddenly. They fade gradually over thousands of years. The most recent glacial period peaked 20,000 years ago, when ice sheets covered much of North America and Europe. The transition to our current interglacial period took roughly 10,000 years. During this time, glaciers slowly retreated, leaving behind characteristic landscapes, U-shaped valleys, moraines, glacial lakes. The Great Lakes formed this way, carved by ice and filled as glaciers melted, were still, in a sense, emerging from the last ice age, living in a relatively brief warm period. Subduction zones are where one tectonic plate slides beneath another, recycling oceanic crust back into the mantle. As the descending plate sinks, it carries water and sediment with it. At depths of about 100 kilometers, increased temperature and pressure cause the plate to release this water, which lowers the melting point of the overlying mantle rock, creating magma that rises to form volcanoes. This process recycles Earth's surface. Oceanic crust, created at mid-ocean ridges, eventually returns to the mantle at subduction zones. The planet is a closed system, constantly recycling its materials. Loess is wind-deposited dust that can accumulate into thick deposits. During ice ages, glaciers ground rock into fine powder. Winds picked up this glacial flour and deposited it in massive blankets across landscapes. The Loess Plateau in China has deposits up to 300 meters thick. This sediment is very fertile, making Loess regions important agricultural areas. But Loess erodes easily when vegetation is removed, creating deep gullies and badlands. What wind deposited over thousands of years, water can remove in decades. Different elements working in sequence, shaping and reshaping the land. Fulgurites are tubes of glass formed when lightning strikes sand. The electrical discharge melts the sand, which instantly fuses into glass as it cools. These hollow, branching tubes follow the path the lightning took through the sand, sometimes creating glass roots extending a meter or more underground. Finding a fulgurite is like finding a frozen lightning bolt. The sand along the path reached temperatures above 1,800 degrees Celsius for a fraction of a second. Lightning captured in glass, energy transformed into form, violence becoming beauty. Continental drift is still happening. South America and Africa are moving apart at about 4 centimeters per year as the Atlantic Ocean widens. The Atlantic is a young ocean, only about 180 million years old. The Pacific is shrinking as the continents around it gradually move inward. In about 250 million years, continents may merge again into a new supercontinent, though its configuration remains uncertain. The dance of continents is slow but perpetual. They've assembled and broken apart multiple times in Earth's history. Land masses that seem fixed and permanent are actually drifting on the moving mantle. Karst topography is landscape shaped by the dissolution of soluble rocks like limestone. This creates distinctive features: sinkholes, caves, disappearing streams, and springs. Water flowing underground, rather than on the surface, creates complex cave systems. In some karst regions, rivers vanish into sinkholes and reappear kilometers away from springs. The landscape is honeycombed with cavities and channels, though most remain hidden underground. About 25% of the world's population depends on water from karst aquifers. Beneath apparently solid land lies a maze of passages carved by patient water over millions of years. Glacial polish occurs where glaciers grind rock surfaces perfectly smooth. As glaciers flow over bedrock, rocks embedded in the ice act like sandpaper, polishing the surface beneath. In places where ice has recently retreated, you can find bedrock polished so smooth it reflects like a mirror. Sometimes, glacial striations accompany the polish, parallel scratches showing which direction the ice moved. These features remain fresh, looking for thousands of years in stable climates. Mountainsides in Yosemite still show polish from glaciers that melted away 13,000 years ago. Evidence of ice preserved in stone. Springs form where groundwater emerges at the surface. This happens where the water table intersects the land surface, or where impermeable rock forces water upward. Some springs flow constantly, fed by vast underground aquifers. Others flow only seasonally. Spring water has typically been filtered through soil and rock, emerging clear and cold. Many civilizations have developed around springs, reliable sources of clean water. Some hot springs have been flowing for thousands of years, their flow rates barely changing. Water that fell as rain months or years ago emerges from darkness into light, beginning a new part of its endless cycle. Alluvial fans form where steep streams empty onto flatter ground. As the stream slows, it deposits sediment in a fan shape. Over time, the stream shifts position across the fan, building it outward and outward. From above, these fans are beautiful geometric features, perfect semicircles of sediment radiating from mountain canyons. In arid regions, multiple, overlapping alluvial fans can merge into continuous aprons along mountain fronts. Ancient alluvial fans, now hardened into rock, tell us about mountain ranges that eroded away millions of years ago. Geography written in grains of sand and stone. Mud cracks form when clay-rich sediment dries and shrinks. As water evaporates, the clay contracts, pulling apart and creating polygonal patterns. These cracks can be preserved if sediment fills them before the next flood. Geologists find mud cracks in rocks millions of years old, evidence of ancient lakes or tidal flats that dried and were then buried. The patterns are consistent across time. Modern mud cracks look identical to those from the distant past. Simple physics of drying clay, repeated endlessly through Earth's history. Even ancient mud records the rhythms of water's presence and absence. You might be feeling tired now. That's perfectly fine. Breathe slowly. Feel the cycles. Water evaporates, condenses, falls, and flows back to the sea. Rock breaks down to sand. Sand washes to the ocean, becomes stone again. Mountains rise and erode. Oceans open and close. All are circles, cycles, endless patterns. Like your breath. Inhale, exhale, inhale, exhale. A small cycle within the vast universe of cycles. You are also part of that eternal movement. You don't need to hold on to anything. Let everything unfold in its perfect order, like continents silently drifting on their plates. Unhurried, unresisting, simply existing. We're almost there now. Dew forms when surfaces cool below the dew point overnight. Water vapor in air condenses into tiny droplets on grass, leaves, spider webs. Everything glistens. This is the sky giving back the water it held as invisible vapor. In deserts, some beetles survive on dew alone, collecting drops on their bodies in the early morning. Plants drink it through their leaves. By mid-morning, the dew evaporates, returning to invisible vapor. A daily cycle of water changing form. Hidden moisture made briefly visible. Frost flowers are delicate ice structures that form on young sea ice. When very cold air meets relatively warm ocean water escaping through cracks, water vapor freezes instantly into beautiful crystalline formations that look like white flowers blooming on ice. They last only hours before wind destroys them or they melt. Sailors in polar regions might see fields of these ephemeral ice blossoms covering newly frozen leads. Nature, creating art from temperature gradients, here for a moment, then gone. Stone stripes occur on hillsides in polar regions where freeze-thaw cycles sort rocks by size. Repeated freezing and thawing causes larger rocks to slowly migrate downhill, while finer soil remains between them, creating parallel stripes of different-sized material running down the slope. The process is so slow that individual rocks might move only centimeters per century. Yet over thousands of years, random piles of mixed rock and soil self-organize into patterns. Order emerging from chaos through simple physics repeated countless times. The Dead Sea is so salty that swimmers float easily on the surface. This lake is 8 times saltier than the ocean, about 34% salt. No fish can survive here. Hence the name. The salt comes from minerals washed in by rivers over thousands of years. But the Dead Sea has no outlet, so water only leaves by evaporation, leaving minerals behind. The lake is shrinking now, becoming even saltier. Eventually, it might dry completely, leaving vast salt flats. Blood falls in Antarctica is a waterfall of iron-rich water flowing from beneath Taylor Glacier. The water emerges bright red due to oxidized iron, essentially rust. This water comes from a lake trapped beneath the glacier for millions of years, isolated from the atmosphere. Microbes live in this dark, cold, salty lake, surviving on sulfur and iron compounds rather than sunlight. The red cascade against white ice looks almost impossible, a bleeding glacier. Life and chemistry creating art in Earth's coldest desert. Rainbow eucalyptus trees have bark that peels away in strips, revealing bright green inner bark. As this exposed bark ages, it changes color from green to blue, purple, orange, and finally brown before peeling again. A single tree can display all these colors simultaneously, creating a living rainbow. These trees grow in tropical regions where heavy rain keeps the bark moist enough to peel continuously. The tree sheds its skin in colors, growing and revealing itself in layers. Bioluminescent bays glow at night when waters contain high concentrations of dinoflagellates. Any movement, a swimming fish, a paddle stirring the water, rain falling, creates trails of blue-green light. Kayaking through these bays at night is magical. Each paddle stroke creates swirls of light. Your hand through the water leaves a glowing trail. Fish become visible as moving stars. The water itself seems alive with light. Chemistry meeting motion, invisible organisms, revealing themselves only when disturbed. The sea illuminating its own life. Mammoth Cave in Kentucky is the world's longest known cave system, with over 600 kilometers of mapped passages. More discoveries continue. Explorers have been mapping this cave for centuries, yet it still holds unexplored areas. Underground rivers flow through darkness, carving new passages while old passages slowly fill with sediment. The cave is a hidden world beneath ordinary farmland. Vast chambers and narrow crawlways, underground waterfalls and still pools. All created by water, darkness, and time. Singing sand dunes emit low-frequency sounds when sand avalanches down their slopes. This phenomenon, called singing sand, sounds like humming or booming. The exact mechanism remains debated, but involves synchronized vibrations of sand grains as they slide. Not all dunes sing. The sand must be a particular size, very dry, and have specific properties. Desert wanderers have reported these sounds for centuries. Dunes that hum to themselves, giving voice to the slow movement of countless grains in harmony. Fairy circles are mysterious bare patches surrounded by grass, found in African and Australian grasslands. These circles are remarkably regular, evenly spaced across the landscape like polka dots. Scientists have debated their cause for decades. Are they created by termites or by plants competing for water in a way that creates regular patterns? Both explanations have evidence. Nature creates its own geometry across vast landscapes, patterns emerging from invisible interactions beneath the soil, mystery preserved in circles. Brinicles occur when supercold brine sinks through Antarctic waters. As sea ice forms, it expels salt into the water below, creating streams of dense, freezing brine. These descend like invisible fingers, reaching toward the sea floor. Where they touch, life pauses. Starfish and urchins, surrounded by spreading ice circles. A strange meeting of salt, cold, and time beneath the frozen surface. The process creates delicate tubes of ice extending downward, connecting surface to seafloor in columns of frozen seawater. Underwater icicles in the coldest ocean. Underwater waterfalls occur where dense water flows over underwater cliffs. Near Mauritius, sand and silt flow off the shelf edge, creating the illusion of an underwater waterfall when viewed from above. The falling water is actually sediment being pulled by currents into the deep ocean. But there are also true underwater waterfalls, where dense, salty water pours over barriers into basins, complete with cascades and pools, waterfalls beneath the sea, invisible from the surface. Living rocks called lithops are plants that look almost exactly like stones. These succulents from African deserts have evolved to mimic the rocks around them, color, texture, shape, making them nearly invisible to herbivores. Most of the plant is underground. Only 2 thick leaves appear above ground, sitting flush with the soil like a split pebble. They flower briefly, producing a white or yellow bloom that seems to emerge from stone itself. Life hiding in plain sight, disguised as the non-living. The door to hell is a natural gas crater in Turkmenistan that has burned almost continuously since geologists deliberately set it on fire in 1971. The crater formed when a drilling rig collapsed into an underground cavern. To prevent methane gas release, engineers lit it on fire, expecting it to burn out in weeks. Decades later, it still burns, a pit of flame in the desert. An accidental creation, now a permanent fire, the earth breathing flame into the darkness. Morning glory clouds are rare rolling cylinders of cloud that can stretch up to 1,000 kilometers. These form in specific atmospheric conditions, usually near coastlines. The clouds move steadily forward like horizontal tornadoes but are smooth and structured. Glider pilots in Australia seek them out, surfing the updraft ahead of the cloud. The clouds appear most mornings in certain locations, then dissipate by mid-morning. Atmospheric waves made visible, tubes of cloud rolling through the sky like breaths. Blue holes are underwater sinkholes found in shallow seas. These circular, deep blue pools in lighter, shallow water are entrances to flooded cave systems. The Great Blue Hole in Belize is over 300 meters across and 120 meters deep. Divers descending into these holes pass through different layers of water, sometimes encountering stalactites formed when the caves were dry during lower sea levels. Past merged with present, caves drowned by rising seas. Ice spikes sometimes form in ice cube trays, thin towers of ice rising from individual cubes. These occur when water freezes from the outside in, trapping liquid water in the center. As the remaining water expands while freezing, it pushes upward through a small hole in the ice surface, building a delicate spike. The spike grows until all water is frozen. Simple physics, unusual results. Tiny ice towers growing in darkness as freezers hum. Order emerging from cold. Wave rocks are cliffs carved by erosion to resemble enormous breaking waves frozen in stone. The most famous is in Western Australia, a rock formation 15 meters high and 110 meters long, shaped exactly like a wave about to crash. The shape formed through weathering and chemical action at the base of the rock over millions of years. Stone flowing like water, capturing motion in stillness. A permanent wave that never breaks. Sailing stones in Death Valley move across the desert floor, leaving long trails behind them. For decades, no one witnessed how they moved. Eventually, scientists discovered the mechanism. Thin layers of ice form overnight, and wind pushes the ice sheets, dragging the rocks embedded in them. The rocks sail across the wet playa surface. The mystery solved yet remains wonderful. Stones traveling slowly across flat Earth, writing their journeys in mud, moved by ice and wind. Bioluminescent waves appear along some coastlines during red tide blooms. At night, waves break in brilliant blue light, every crash and foam illuminated. Walking on the beach, your footprints glow. Throwing a stone creates a splash of light. The ocean transforms into something magical, though the organisms creating the light are the same ones that can harm marine life during daytime. Beauty and danger intertwined. The sea lighting itself up in darkness, revealing invisible life. Arches form when rock erodes differently based on its structure. Water, ice, and wind enlarge weaknesses, cracks, soft layers, joints, until they pierce through the rock. What was solid becomes hollow, and eventually forms an arch. These structures are temporary on geologic timescales. They stand for thousands of years, but eventually they collapse, returning to rubble. Arches are moments in time, transitional structures between solid and gone. Rock briefly defying gravity, creating doorways that frame distant views before falling. Geodes are unremarkable rocks on the outside, but contain crystals inside. Gas bubbles in cooling lava or dissolved cavities in sedimentary rock slowly fill with mineral-rich water. Over millions of years, crystals grow inward from the walls. Quartz, amethyst, calcite. Breaking open a geode reveals a hidden crystal cave, sometimes small enough to hold in your hand. Beauty hidden inside ordinary stone. Patience rewarded for those who look deeper than surfaces. Fire rainbows aren't rainbows or fire, but rare optical phenomena called circumhorizontal arcs. These form when sunlight passes through ice crystals in high cirrus clouds at a specific angle. The entire cloud lights up in rainbow colors: brilliant red, orange, yellow, green, blue. They appear as horizontal bands of color across the sky, parallel to the horizon. The effect requires the sun to be very high, ice crystals properly aligned, and an observer at the right angle. Geometry creating color from light and ice. Sea stacks are isolated towers of rock standing offshore, remnants of eroded cliffs. Waves exploit weaknesses in coastal cliffs. Softer rock, cracks, faults. Over centuries, caves form and enlarge, eventually breaking through to create arches. When arches collapse, isolated pillars remain. These stacks stand against the waves until they too erode and collapse. The 12 Apostles in Australia are famous examples, though fewer than 12 remain. The sea slowly claiming back what was once shore. Eternal flames burn, where natural gas seeps from underground. Ancient civilizations built temples around these spontaneous fires, considering them sacred. The eternal flame falls in New York is a small waterfall with a flame visible behind it. Gas seeping through shale keeps the fire burning even behind flowing water. In many places, lightning or human activity ignites gas, seeps, creating fires that burn for years or decades. Earth-breathing fire, sustained by invisible reservoirs of ancient organic matter, transformed underground into fuel. And so, our quiet journey through Earth's powerful forces comes to a gentle close. We've traveled from the slow grinding of tectonic plates deep beneath our feet to the delicate formation of frost flowers on polar ice, discovering along the way that what we call disasters are simply Earth being Earth, reshaping itself through processes that have existed since the planet formed. From volcanic fire to glacial ice, from earthquake tremors to the patient flow of rivers, we've glimpsed how our world is both powerful and gentle, destructive and creative, constantly transforming itself through forces that recognize no difference between the two. Earth's natural forces remind us that change is the only constant. Much of the transformation happens in silence, plates sliding beneath us, water carving stone grain by grain, in darkness and patience. These forces teach us that power and gentleness can coexist. Without earthquakes, mountains would never rise. Without floods, valleys would not renew their soil. Without volcanic eruptions, islands would never be born. By pausing to understand rather than fear, we glimpse the extraordinary patience in every stone, every drop of water, every breath of wind. And now, in these final minutes, take the deepest breath you can, as deep as possible. Think about unity of every atom, every grain of sand, every drop of water on Earth. The water in your body has flowed through rivers, fallen as rain, risen as mist. The calcium in your bones was once limestone, was once shells in ancient seas. You are not separate from these forces. You are made of earth, standing on earth, breathing Earth's air. Think about how water cycles through clouds, rivers, oceans, and rain. Everything is connected. Everything returns. Everything flows. You are part of that flow, that cycle, that eternal return. Let your entire being dissolve into the rhythm of nature, into the breath of the earth, into stillness. Allow deep sleep to find you. No boundaries left, only peace. If these calm stories from Earth helped you breathe a little easier, passing them along could help another tired soul drift into rest. A gentle share might bring peace to someone else awake tonight, someone else seeking to understand the world's forces without fear. One quiet share, one peaceful night at a time. But there's no need to do anything now. Nothing at all. You've traveled far tonight, across continents, through time, beneath oceans. You can allow these thoughts of Earth's powerful forces to fade now, like morning mist dissolving in sunlight, leaving only the quiet calm behind. Let your breathing deepen. Let your body feel heavier, as if gravity itself is gently pulling you down into rest. The same force that holds planets in orbit and pulls rain from clouds. If sleep comes, let it carry you like a leaf floating on a calm river, smoothly, inevitably, into a realm where time and weight no longer matter, where nothing needs to be understood or remembered. If your eyes are still open, the next video is waiting for you, ready to continue the journey. But if they're closed, stay there. Stay in the darkness that feels safe and warm. Tomorrow, the tectonic plates will still be moving. Rivers will still flow to the sea. Mountains will rise grain by grain. The water cycle will continue its ancient dance. But tonight belongs to stillness. Rest well, fellow traveler. And remember, every storm passes, every volcano quiets, every earthquake settles back to silence. Nature's power is temporary. Peace is what remains. Dream deeper with bedtime science. Good night.